Hey folks, Larry here. I haven't been making videos as often because I've been heads down working on the platform that I talked about last time. I'll give an update towards the end. But here, I want to share my thoughts on how to succeed in the AI era. Now, I'm very optimistic about AI. I think this is one of the most important technologies ever created in history. But like every other technology, it's a tool. It's not going to make humans obsolete. It's not going to replace humans or whatever the doom and gloom media is saying today. Instead, it'll supercharge your creativity if you have the fundamentals down. If you don't have the fundamentals, then you're just going to be generating slop. Now, I think there's really just one mindset slash strategy that you got to adopt in order to succeed going forward, and that's whenever you do anything, focus on extracting out the generalizable principles. Understand them deeply. See how they can relate them to other areas. See how they can be used in a variety of different places. And you got to be diligent about this. You can't just like passively go through the motions. You got to consciously try to find the connections and figure out the applications. So, for example, let's say you're building a file system. A file system it's essentially just a tree that stores the files as nodes. That is the principle. And you got to recognize that. Don't get bogged down on the implementation details. As you're building, your goal should be to understand trees themselves. The files, they're just there to give you concrete direction. You want to dive deep into the nitty gritty details. That's where the real learning occurs. That's where the foundational patterns reveal themselves. You're going to run into a bunch of challenges that a lot of the time you might not have even anticipated. Like, say, dealing with concurrent reads and writes. If one guy reads half a node and then some other guy writes to it, you can't just continue reading the other half unless you want to mix together recent and outdated data, which is usually not a good idea. So try to solve these problems on your own. Don't ask the AI to explain stuff to you unless you're really stuck. Your goal is to understand the structures. That's what's going to enable you to solve a wider range of challenges. I guess if you've seen the problem before, okay, you're not going to learn as much, so go ahead and ask the AI generate a solution and move on. But otherwise, play around a bit, and you'll realize, going back to the example, that you could treat the nodes as critical sections. You could use some sort of locking mechanism to protect them. It's a pretty good solution. So you implement, and there's probably some bugs, so fix them, and you'll have learned all sorts of things. You'll have seen all sorts of connections. One of them could be that locking is not just limited to trees. You can use it to protect any sorts of data against concurrent access. It's just that the tree allows you to be more specific in your implementation. So you could try and generalize, and you should. But spend time, bang your head against the wall, and you'll find the deep patterns that show up in other places. Now, when you're incorporating solutions, you want to keep in mind how they fit into the overall structure of your program. You probably want to abstract them out so other parts don't need to worry about it. For example, you could abstract out the concurrent read-write stuff into a set of functionalities that you use to like implement traversals. Then the traversals don't need to deal with concurrency handling. And then you could use traversals to implement some of the higher level stuff like searching, like listing stuff in a directory, permission evaluations, etc. That's another principle, by the way. Build the basic functionalities and then compose them into higher level ones. This is really important for developing complex systems. If you try to build everything all at once in the same place, you're going to get a mess. So don't do that. But yeah, principles show up everywhere if you're looking for them. Now, let's say sometime later you're working at a company, you're tasked with building some sort of thread-based messaging system, so users can reply to messages, and that'll create threads. And there could be lots of nesting. Maybe you're building this out for customer ticket handling or something, but there's a good reason why it needs to be thread-based. This looks a lot like the file system. There's a tree that stores the messages as nodes, and the threads, they show up naturally due to the tree structure. There needs to be traversals. There needs to be concurrency handling. You've pretty much already built this before, just in a different context. So you should already know like what to expect, how it should work. You'll be able to come up with the program structure pretty quickly. But the implementation details might differ this time because you're working with internal systems. You might have to integrate a database, but the principles are the same. So you just apply them, come up with the architecture, and then you get AI to do the implementation. Your prompts will naturally be very specific because you already have a clear mental model in your head. And that's going to really improve AI outputs compared to if you just put in something vague. In fact, speaking of the outputs, you pretty much like before you even like hit and before you even prompt, you already know like what the output should look like, so you can review it quickly. You just kind of skim it. You already know what's going on. You can also parallelize effectively across AI agents. But with AI, you just build this thing out so fast. Now, suppose you don't know anything about trees or traversals or concurrency, and you're given the same task. You don't know how to structure the program. You might not even know how to program. So you give it a prompt that starts with build a thread-based messaging system for customer ticket handling. You add in business requirements, you add in more details, but you don't mention anything technical. And then you hit enter, you let it rip, uh, you wait a little bit, but then it gives you back a thing that is not at all what you asked for. There's missing features, lots of bugs, integrations aren't working, and then you go do some QA. Uh, and tell it to fix the issues, but they're not fixed. More issues appear, and you enter this infinite loop of doom where you tell the AI to fix stuff, but they never get fixed. Instead, like more problems just get introduced. So you start again, but this time you get the AI to generate something simpler, like a message list, without any threading. You relax a lot of business requirements, and it gives you something that works, maybe. But as soon as you tack on more complexity, it's gonna break, and you'll have no idea how to fix it. Yeah, I can't fix it either. Back to the infinite loop of doom, and you'll have spent a lot of time trying to build a system that just does not work. The thing is, AI is incredibly good at implementing specifics, and not so great at coming up with architectures from high-level prompt statements. And that's because it lacks judgment. See, to arrive at an architecture, you have to deeply understand the problem, the domain. You have to deeply understand the context. You have to figure out, you have to know what principles to apply and how to apply them. You also have to sort through a bunch of details that might be hard to anticipate. Oftentimes, the real problem is not at all what was originally stated. So you have to realize that and do something else instead. The new models don't seem to be getting that much better at this. You still have to use your own judgment to figure out the structure and then prompt accordingly. If you just tell it to build something high level without specifying any technical details, more often than not, it's just not going to work. Or maybe it works at first glance, but as soon as you test out some edge cases, it'll just break. Oh, and don't look at the code. Wait, don't look at the code. There's nothing to see there. Though I will say the models are getting a lot better at specifics. They'll come with some really good solutions in narrow domains if you give it the right details. Just don't be vague. One of the things that I've been doing recently is having the AI come up with bits and pieces of architecture. Sometimes it'll suggest some really neat algorithms, but often it's not so great at fitting them in or configuring them, so I have to direct it further. Basically, it'll give you a good starting point, but you got to fill in the gaps. This is where I should disclose that I rarely write code by hand anymore. I'd say probably like 90% of my code is AI generated, but I don't vibe code. I put in a lot of thought into how the system is supposed to work, and then I prompt accordingly. I also ask the AI for ideas. It's kind of like this partner that knows everything but understands nothing. There's a difference between knowing and understanding. I have a friend who, by the way, is very successful, but he had this quote: knowledge is free, thinking is the new commodity. And that is so true, because you can ask the AI to tell you anything and it's pretty accurate, but you still have to extract out the foundational principles and fit them into the big picture. It's like you take the knowledge, you do the thinking, you come up with the prompts, hand it over to AI, and it'll give you some really good outputs. You can also ask the AI to like guide your thoughts. You can ask it to like review your ideas and critique it, evaluate it. Just don't like take it verbatim. Make sure you're critically reviewing what it's telling you. Don't outsource your thinking. If you don't do any thinking, it's not going to work out too well. Going forward, I see the key interactions between humans and AIs as being the human will take on the high level problems, find solutions, find workflows, and then get AI to do the implementation. And these problems will be very vague, ambiguous, not a whole lot of details supplied, but if solved, will have a huge impact. So, for example, if you're working at a company, one of these problems could be there's this internal tool that we want to productionize and get in the hands of customers. Figure out how to do this. and you might not have even seen the tool. You might not have even heard of it. So you got to do some research, and then you need to see how it fits into customer workflows. Maybe there's like some gap. There's probably going to be some gaps or a lot of gaps that need to be addressed, and there's tons of like details before you can productionize it and generalizations and so on. Or maybe you just pivot altogether because it turns out the customers don't want to use your tool. But instead, they want to use something that can be built by adapting it. This was usually how software engineering was done. The implementation wasn't usually that difficult. It was just manual and time consuming, error prone. You had to sort through, or you had to read through a bunch of documentation that wasn't necessarily applicable to you, or you had to dive into code bases that you've never seen before because the documentation didn't exist. Then there's the actual writing of code and debugging, which again, not necessarily that difficult. Um, but it was like just manual and time consuming. Well, AI has a lot of that automated now, so the menial work is pretty much all gone. You can prioritize the more impactful problems now. Basically, if you have the right foundations, you can do so much more on your own if you have the right foundations, which is acquired through the pain and struggle of sorting the hard details on your own. Can't skip that part, unfortunately. If you just ask the AI to explain everything to you, you're not going to cultivate the foundations as effectively. You won't develop judgment as well. You really have to struggle and suffer on your own. There's no other way. No pain, no gain. But you just have to do this once, and then your productivity goes up quite a bit. So essentially, AI rewards fundamentals, and it punishes the lack of it. I actually believe the era of the let's say static career is over. These are the career. This is where you learn a skill and then repeatedly do that for 20 or 30 years. Things just change so fast now. I don't think you can do that anymore, and that's not such a bad thing. Like, do you really want to do something repetitive for years or decades on end, or would you rather tackle challenges and be innovative? Now, I personally do not like doing repetitive work at all, so I'd rather take on the challenges and innovate. Before AI, building anything complex required a dev team and funding, but now you can sidestep all that. It's easier to build than ever before. That also means it's easier to create slop than ever before. There's way too much of that on the internet. But yeah, I mean, use these tools to your advantage. Build something complex. Build something impressive. Show it to folks. Network around. But only show the good projects. Don't just paste in the AI slop. Everybody's sick and tired of that. Also, don't think about the money. Pursue your interests. Do it because you enjoy it, not because you want to get paid. Otherwise, you're going to always feel exhausted having to keep up with the rapid pace of development. Now, some people tell me that they're not interested in everything or they're not interested in anything. And I just find that really unlikely because there's always something out there for everyone, and they just haven't discovered it yet. So broaden your horizons, try new things, get into that habit. It could seem scary, but it's really not once you get to the habit. Just continuously like pushing yourself and doing something new. But you will make mistakes. You're not always going to produce the best work, and that's perfectly fine. That's natural. You got to make mistakes in order to improve, but just keep pushing yourself and learn new things, solve problems, learn more things, solve harder problems, rinse and repeat. If you can get into that cycle, you're gonna do fantastic. All right, so that's it. But before I go, I'll give an update on the platform. Last time I showed this, which is part one of the introductory Python sequence. The first goal is to get my software engineering roadmap on here with a bunch of worlds that you can program and explore using what you've learned. There's also these bite-sized modules down here. I'm not gonna go into this that much because I've already shown it last time. Actually, you know what? I'll just go into this this right here as a recap. Um, so these are bite-sized learning modules. I'm going to explain the intuitions and foundations from first principles, so you can actually understand. It's going to be rigorous instead of like I'm not just going to like explain the syntax and call it a day. Actually, let me just do this. Times 60 times 60, and there you go. So of course, like this is pretty simple because it's just intro to the Python. It's like early introduction to Python. Later on, there will be big challenges. I think there's a decent chance I'll make the final project, like build an interpreter or compiler of some sort, something like that. It'll go deep. Don't worry, like you'll learn a lot, and everything will be explained. But yeah. Anyways, let's go back here. Now these worlds up here, I didn't get a chance to show them last time. They're programmable 3D worlds on the web. You use what you've learned to navigate them. So actually, let me unlock this and let's in here real quick. Yeah. So this one, for example, you got to program. You got to supply a program to charge the portal in the center, and there's instructions over here. So let me just supply the program real quick. There we go. That's the program, and now I'm gonna hit run, and it's actually going to your program's actually going to interface with the stuff in the world. Let's wait for this portal to charge. All right, and there we go. So it's not that complex. This is just part one of introductory Python. After all, you only have access to basic constructs, so I can't make it too complicated. Part two is where I want to make the more sophisticated worlds, and that's the part that will explain functions and references. You really need functions and reference types before you can do anything complex. And of course, like I don't want to just explain what they are and call it a day, since this topic is really important. I want to dive deep into the intuitions, how to break programs down, how to think about it, like signatures, call stacks, basically how to think about the stuff deeply, which is really important in the AI era, as we just discussed. And in particular, there's actually two worlds that I want to make. One is a tower defense game, where you program towers to fight enemies, which will have you unlock new towers. The other is factory builders. You program machines to fulfill orders. And of course, it's going to be rewards. I'm not sure how big I want to make these. They'll definitely be bigger than this world. That's for sure. But I also don't want to distract from the learning. It's like a balance that I have to strike. And plus, like, they're part of the sequence, they're not standalone worlds. The standalone worlds are really the big, sophisticated games, and you unlock them from the items in the shop. Actually, let me go back. So you unlock them from the items over here. I might make a bigger tower defense or factory building game as a standalone world. Not sure yet. There's a ton of ideas I'm playing around with right now, but I'm just starting small, not trying to bite off more than I can chew. I'm also learning game dev and 3D graphics / art. This stuff is new to me. I actually spent a ton of time on the art, had to learn a bunch. I actually modeled this. Actually, let me go back. Here. So I actually modeled this scene in Blender, and that's my first time like using Blender. I never I basically knew nothing about 3D art up until now. I did try some of the AI tools for 3D modeling, and they're just not quite there yet. They're actually pretty bad, to say at least. But like the 3D graphics stuff was by far the hardest part of the project, just getting the asset pipeline set up and all the infrastructure. Honestly, like the other stuff, the UI, rewards, coding, getting a Python interpreter running on the web, like that stuff wasn't really like that hard. But this one, like the 3D stuff was actually quite challenging. But here it is, like the infrastructure is built, making these worlds going forward is gonna be a lot faster now. And I don't want to build another LeetCode style coding platform. I want this to be unique and actually teach the deep fundamentals. Later, there's going to be formal math. There's going to be algorithms, physics. You actually have to prove theorems. They're going to really challenge you. It's not going to be like those multiple choice trivia or like super basic stuff. Like it's actually going to go deep and explain the foundations rigorously. And hopefully it'll be artistic as well. You know, I'm still working on that part. I'm still like learning art. But the worlds will be built so that they will really test your understanding while showing you the applications, helping you see the connections between things. That's the motivation for having them in the first place. And plus, it breaks the monotony. I think people would rather progress game worlds than read walls of text. And so if those game worlds actually help them learn the deep stuff, I think that's going to be, at least for me, I think that's going to be interesting. But yeah. All right. So that's actually going to be it for this video. If you're interested in tech and you want to chat, please join my Discord. Links in the description below. And I will see you next time.